My channel Balbigyan Bharti, and this is your mentor Vilas Sarkar. Now, as I said, we are already completed the binomial theorem, and we're going to start a new chapter that I already declared is a probability. Now, before going into the subjects in details, the term probability that signifies, if I see the literature meaning of that probability, it does mean that which is something predictable, means you have to predict that one. It's not a certain thing is happening, it is probable reason. You used to say what could be the probable reason, what could be the probable result, like that. That means we are not sure about the firm answer, like any numerical answer will get, any such result or unique result I will get, and definitely that I will achieve. If it is not so, that also a part of the mathematics where this kind of uncertainty being related and being studied, and this is pretty much useful for studying several interrelated subjects. Why I'm saying interrelated subjects? Because on basis of this concept, this is definitely a concept. Basis of this concept, there are several subjects are developed where we can go very nearer to the condition, or some rules we can set on the basis of this prediction, and we can predict very near to the expected results or the outcomes. So that probability is, you can understand, is basically based on the uncertainty or we can say basically uncertainty or conditions probable conditions or results, okay, where the results can be predicted but it cannot be definitely said. Okay, so if I define probability is the uncertain outcome, is the uncertain outcome or the probable result among all possible outcomes or result. Am I clear with this definition? If I say this is my own language, it can be different also, but meaningfully if I see this definition, it matches the concept of probability. How the uncertain outcomes or the probable results, both are same, uncertain outcomes or probable results among all the possible outcomes. Means if I do some exercise or experiment where the result could be of anything, means there must be some definite result, but that result we cannot predict certainly. That is the meaning. That means there must be some result but the result which will happen, which will occur cannot be said definitely. Understood? That means if I give an example, that very simple and classic example is that every time during study of this probability people used to say tossing a coin. You usually see it many more times and many where tossing a coin. So you know that coin has two sides of different characteristic. One is you call it head and other end is tail. Okay. So if we toss a coin, you know somewhere or other it will lie on the floor where it will become stable, or on any surface it is being dropped will face something up, either between head or tail. In between these two, this will come up. So that means you can see the head faced up or tail faced up. These are the only two probability it could happen for any tossing of the coin, for any single tossing of a coin. But one cannot say that head will definitely will come or tail definitely will come. That nobody can say. You know, out of this result nothing is possible. If the you can say exercise is not biased. Why I mean to say the bias? Because if the coin stand on its edge on the floor, you won't get any result, because both the face you can see. So this is unbiased. In probability, one such condition is that the experiment or the event, whatever you are doing, or the exercise, whatever you are doing, it should not be biased. It will give a result. The first condition is that you will get a definite result. Okay, but prediction of that result is not definite. Result will definitely get, the prediction of the result is not definite. That means head or tail will come, but either head will come or tail will come, nobody definitely can say. So this is the condition where probability comes in picture. Okay. So what I am saying, that the condition should not be biased and you will get definite result, then only you can predict what is the probability of coming head or tail. Now what we can conclude, if I take that such example for defining my probability, we know perfectly first result must come, no bias. Okay, and the thing is that out of the total outcome, some will come definitely. Okay, now if I see this example, so what is the total number of possible outcome? Total number of possible outcome is what? This could come head or tail. So 1 and plus 1, 2. So total number of possible outcome, either head or tail. So all total 2. In this subject, one more thing that you have to understand and you keep it for your further study in probability. Wherever you will find such condition where out of the two condition or you have to choose, then your total count will be added. That means if your choice is coming either or, that means if or coming in between the two choices, then you have to add to get the total possible outcome. Okay. And the same way, if it is coming and either this or that, this is one condition, this and that, both condition, then you have to multiply. So this is one, you can say, the tips for solving exercise. You have to keep it in mind. Wherever you will get the condition either or, you have to add to get the total of the chances or the possibilities, and if it is coming, then you have to multiply the total, multiply the options to get the total chances. I will come later, but as of now we just remember this one. Okay, so the total number of possible outcomes here, what you are finding, head or tail. If it is coming head and tail, then you have to multiply 1 into 1, that will come total possibility. But here you have to choose head or tail will come definitely one face up, other face will be below that, you cannot see it. So head or tail means 1 plus 1 2. So there are total number of outcomes possible to this is the total number possible, and the preferable or preferable, whatever you say, preferable or favorable, these two terms are meaning the same here. Preferable means if you prefer head to come, when you are choosing batting or bowling in between the two teams which are playing opposite to each other, we make a toss to select whether the team wins will do batting as per their choice. If head comes, then he may choose batting or bowling. Now the team which wins the coin will choose either of these two. So first thing is that his choice will be either head or tail. If he calls head, so the preferable or favorable outcome for the team who is calling for the head or tail is how much? He will choose either head or tail. So number of choices favorable is 1. Either if I see the head or tail. So in this case, the probability will be calculated by, if I say this is favorable outcome is denoted by M and the total outcome by N, then preferable outcome or favorable outcome by the total outcome. This will be the formula of probability. Okay, in this case it is 1 upon 2, half. Now this probability, as it is directly can be represented by fraction only, this can turn into decimal, you know it, you can convert into decimal or percentage, both you can convert, because you have an idea of decimal and the percentage. Any fraction can be converted into this decimal or percentage, or you can keep it in as a result of fraction. Understood? So I mean to say, in this case, the preferable or favorable outcome it's 1, either head or tail. If we choose tail also, we'll get 1, and total in this case between head and tail, head or tail, so total outcome is 2. So my probability will be denoted by the preferable or favorable outcome by the total number of occurrence possible occurrence. You will not see that time which is coming, the total number of possible. Now we'll say another example. It will be more clear, because here you are getting only two option of the result that may come as a outcome, possible outcome. So now if I say another example, tossing a dice. Now in this case, dice, how many numbers are there? 1, 2, 3, 4, 5 and 6, because these are six planed object. That means it is a cube basically. Dice is nothing but a cube, which all surfaces are of equal dimension, and every surface containing a different number starting from 1 to 6. Now in this case, if I say the first is total, if I toss it, total number of possible outcomes. There I will not choose anything, possible outcomes. This could be any result if I toss it. Either I can get 1, can get 2, can get 3, 4, 5, 6, any of the number you will get. You will not choose any of the option, but if you toss it, definitely some surface up will come and will count that surface as my result. Okay. So number of possible outcome should be 6, because this is 6 number. So this case 6. Now in this case, the other thing, number of preferable or favorable outcome. So what could be my outcome? For one instance, if I say I need, when we play Ludo, we toss the dice to get a certain number to fulfill my next step, where I will put my what you can say, the colored dice, discs are there, small discs are there, different color, that have to put inside for any reasons in between. So when you play Ludo, we have a preference of getting certain number. So if that is only one number that we want to get, because certainly in Ludo we'll always ask for one single preferable number. So out of the 6, my preferable number must be 1. Practically when we will play Ludo, while playing means homemade Ludo, okay, not that we are seeing in internet and all that. Generally in a board, 4 color opposite partners are there, and we play with the tossing a dice and some 4 colors, small what we say, small plastic disc type of things are there. Okay, so we played. You know what is Ludo actually. So our preference for that, for every tossing, the person who is tossing it, he needs some number. So that his preference or her preference is only one number. So that number is 1. So in this case, if I say what is your probability, what do you say? Number of preferable outcome by number of total outcome. number of total possible outcome, total number of possible outcome, or number of total possible outcome, whatever it is the same. So preferable or favorable is at the numerator, and total outcome, possible outcome is in the denominator. So in this case, this is 1, this is 6. Okay. So that possibility, probability, you can understand this. Now, if my preference changes, then this probability will definitely change. How it will be so? Now here I said an example of playing Ludo where you will choose only one digit. If it is so, for any other case, my favorable number of preferable or favorable outcome be the odd number. So if I choose, out of this any odd number comes is my preference. Any odd number comes is my preference, or any even numbers, odd number or even number is my preference. So in this case, how that probability will change due to the change in my preference. Now the total outcome, as it is 6 number, is always be 6. Now the changes of the probability depends on the variation in this numerator, and this numerator changes when our preference changes. Now in this case, instead of getting any one single digit, I am asking for odd number or even number. Now in this case, how many even numbers are there? 3. How many odd numbers are there? 3. So if I choose odd numbers, so getting any odd numbers is for any toss, either 1 may come, 3 may come, or 1 or 3 or 5. So total number of choices how much? I said when or will come, we have to add the chances. So either 1 will come or 3 will come. So 1 plus 1 plus 1, 3. So that means if I simplify it, I will get half. Now see, earlier getting any one number, the probability was 1 by 6. But in this case, when preference changes, my probability come down, has increases to 1 by 2. This is definitely higher than 1 by 6. Similarly, if I choose the even number, that also 2 or 4 or 6, anything may come in tossing. If I choose, I want to get even number, so there are the chances of getting even numbers are 2 or 4 or 6, 1 plus 1 plus 1. So the same result for even numbers also, I will get half. Okay. So I will end up here. In the next, I will extend it with further example, and few more characteristics will come out while I am discussing this kind of examples, and we'll set up some formula with this concept. Okay. So thank you for now.